Whoa, come on. Hand tracking, do the tracking. Haha! Evening, everybody. We're going to be wrapping up the remainder of the 30 Days Lost in Space franchise this evening. After I took a look at what day 30 contains, you'll now understand why I'm combining both of these days. No spoilers, but you'll understand soon enough. That's okay. So with that, I don't have too much of a rebuttal. We're just gonna hop into it. I'm a little later to start than usual. That's okay. Still got there. Let's see where I'm at here. I'm gonna press buttons. Particularly those buttons. Alright. Same as usual, we'll just get the little beginning introduction and then we'll dive into it.
Good morning, Explorer.
Hello.
Here we are, on the verge of the conclusion to an odyssey that has tested our spirit, resilience, and intellect. Today isn't just another day. It's the culmination of every challenge we've overcome, every star we've wished upon, and every bit of hope that propelled us forward. Our home awaits us. But before the sweet embrace of familiarity, there's a final task to be done. The docking gear needs one last touch, that certain je ne sais quoi that separates success from blunt force trauma.
Ow.
So, as the horizon of our galactic home draws near, let's pour every ounce of our knowledge and resolve into this final effort. It's time for our grand finale, Explorer. I know you won't disappoint me. All right, Explorer. Here's where the intricacies of our hardware truly shine. Remember our ascent from that alien ocean floor? Upon
Sure
lining
do.
our trajectory with our assigned docking bay, we need to control our rate of approach so we don't prang a landing gear, or worse, upon arrival. We will be using our rotary encoder to control our rate of approach. Come into the docking bay too rapidly, and we crash and burn. Come into the docking bay too slowly, and we risk missing the window of opportunity as our mothership's velocity will take our docking bay off our trajectory. As long as we can keep our rate of approach just right, we can enter the bay and land our ship in our docking cradle. Crashing is not on the agenda today. Let's utilize yesterday's code.
Sure.
Integrate logic for the rotary encoder to regulate our altitude. Dive too rapidly and we plummet tragically. Descend too leisurely and we risk stalling in midair, equally catastrophic. So, precision is the name of the game. Let's ensure our touchdown is smooth as silk. Let's figure out how we plan to code this thing.
Okay, I have to pause her for just a brief second because it's gonna bother me. She said pause mid-air. When you're in the vacuum of space, there is no air. And on top of being no air, there's also really no gravity to pull you in any particular direction. So if you stall, it's just kind of like stalling in the middle of the road. You're just gonna kind of be there. All right, science nerding aside, let's continue.
Using the same code as yesterday, we will need to add the following.
Okay.
1. A variable to track our distance from target airlock.
Love it.
2. a countdown sequence once the docking gear is deployed.
Some of my favorite.
3. A function to use the rotary encoder to carefully approach our mothership,
Okay.
adjusting as needed by following the on-screen instructions.
Excuse
Rise
me.
when it says increase, lower when it says decrease, etc. And 4. A success message to display upon docking. Sounds easy enough. Let's take a look at the cached code on our computer for one last time on this grand adventure.
Mighty fine, mighty fine.
Hello and welcome back to the final
Bye,
day.
Alex. Bye, Alex. Okay. So diving into this. Okay. So if any of y'all were paying attention to what they just said, our diagram definitely doesn't match up with what we're supposed to be doing. Because they said we were going to involve a rotary encoder. I don't see a rotary encoder in this diagram. There's no spinny bits here. There is a 4x4 keypad, which is cool. I'm going to imagine that this is a snafu where they didn't update the video to match the exercise. That's going to be my guess, but that's okay. Because my understanding from last time, I haven't looked at it since then. I perused through day 29 just to kind of get an idea of what we would be doing. And it's going to involve writing code to use the buttons so that we can have kind of like what the thumbnail showed, like a 4x4 directional, so like we can kind of choose where we were going with the ship. But I didn't quite see how that tied into the buttons, other than that maybe launching or ending a sequence. I don't know, we're building on the existing code, so I'm sure that it's probably just the same. These 3 switches are for our ready state, which will then show the lander on the display here. And I'm sure there's going to be some countdowns involved. So we're going to peruse through the code, and we're going to kind of see where that takes us. Because I don't want to go through every line because I know this is building on what we had, but we are going to kind of meander through it. So first things first, just like any other day, we have to start a new project, and then we'll have to import any classes we need. I don't think there's going to be anything we'll have to install because we already have the classes installed in our compiler for all of this hardware, because there's no new hardware. I mean, there hasn't been new hardware in the last like 3 or 4 exercises. But that's okay. That should just mean we have all the libraries we need already pre-installed. So let's do that. So first things first, before we even look at the code, let us get ourselves in a position where we could do something. So we're going to open up our IDE. We're going to make a new project, and then we're just going to bring over the code. Before I close out day 28, which opens automatically, this will always remember the last project you were in. Oh, look at that. There's some updates to the libraries. Good. We're going to let that do its thing. Sure. Yeah, we might as well. We're live. When is that? Or there not a better time to do a software update? As they say, watching everything catch on fire. I'm sure it's fine. I'm not updating OBS. It's fine. I'm updating libraries. At least those are stable. All right. I want to wander through here. Oh, I'm glad to hear you're enjoying vacation, King. Very nice, very nice. Welcome on in, by the way. I emoted, but I forgot I have closed captioning, so I can actually say hello. I made sure that was working, because I started it, and then the closed captioner told me it wasn't running, but it was. But it wasn't, but it was. You gotta love technology. Well, I hope wherever you decided to go, King, that that it's a fun place. Okay, so again, before I open day 29, we're going to wander through here because I did copy day 28 directly from. I want to swing through here and see, because I think there was some commented out code that technically gets uncommented, quote unquote, for day 29. And I wanted to see here. Yeah. Okay, so there's some code here where we're going to actually print to the terminal our readiness state in addition to actually making the display do stuff. So that should be added in. It looks like we're going to involve another bitmap. Flash lander bitmap if gear is down. Displays each bitmap centered in the display based on its size. Oh yeah. So then there were some new switch cases. Okay, so I thought I remembered seeing something in here that was commented out, where we have our active, completed, or abort based on what we're going to have the switches in. Now, we may have to watch a little bit of the video to understand what the keypad's all about, but no here nor there. We're gonna get this going, and we'll run with that. Ooh, oh, I love the Hilton. They're a good hotel chain. Let's see here. So I'm going to save. As day 29 and 30. All right, I can close that one out. And then we're also gonna need to remake our bitmap. Our bitmap should be below the code here. I think that involves some new bitmaps too, so it's a good thing we're bringing over the code fresh anyway. Oh yeah, look at that, we got a couple of them. We got ending bitmap, radar, arrows, small landing gear. Be sure to keep in the same folder as the main sketch. Right, okay, yeah, let's get these moved over. See if I remember how to do this. Lines, and I want a new tab called that without the extra space. Now, for those of you who are not here before, I'm going to cover, so what the bitmaps are is a code representation of a picture. And that's what everything is in this center block. And what we get to do is we get to copy all this and put it in our separate file we made for the bitmaps. You do not have to put your bitmaps in a separate file if you didn't want to, but as you're going to see here, it's going to be much nicer and neater to move all of this code that makes up the pretty pictures, the graphics, into its own thing because of how big it is. Because we're going to have 3 different graphics, which involves 3 separate bitmaps. These things are pretty big. So in an effort to keep the code a little cleaner, we're going to make these their own thing. And then all we have to do is include them in the main code. And that's where this name is going to come into play. So we're going to pull on the radar underscore arrows.h, and the same thing with endings underscore bitmaps.h. Do not forget the H or it won't work, as I found out in a previous episode. So we do another new tab. And then we're going to bring that over. Okay. Interesting. Okay, so we're actually going to be drawing some really basic graphics for arrows, it looks like, which is going to be probably how we're going to direct the landing gear. Interesting. Okay, well, we're going to see here how all this ties in. And then, oh, small landing gear. Okay, so probably a more condensed landing gear. Now, I am going to power on the previous exercise before we change the code on it so we can see the visual difference between day 28 and day 29/30. because even I could use a refresher on that, on what it looked like before and what it's going to look like today. Now, a lot of the main code is going to be the same, but we're going to kind of peruse through it. Not gonna lie, that's probably gonna make today's stream a little shorter, but I don't think we really need to cover all of the concepts. By all means, if you have any questions while I'm going along through any of this, please ask. I am more than happy to explain in a greater detail if you have a question. As I'm working my way downtown. When the code was small, I used to bring this over in chunks, but now that we've gotten kind of long, it's a little more difficult to do that. So we're just going to bring this all over in one shot, and then we're going to wander through it. The one thing I do need to figure out for myself personally through all this is how to successfully generate a bitmap. Because I've tried two different ways, or two different episodes where we were working on this, and I've still failed to make something that actually looks like what I intended. Which I'm not going to lie to you is very frustrating to me, because I'm not sure what I'm missing by using this image to CPP website thing. But I'm not too worried about that for today. But it's something that I do want to revisit at some point. Because I can tell you right now that in the midst of building a protohead, I'm going to need to know how to make bitmaps. Because I'm really under the impression that I want to do a protohead based on the Arduino suite, since this is what I've been getting into. There's a lot of different exercises out there, and I have made it no secret that I want to build a protohead. So much so that if you're in my Discord, you'll see that I built some new sections. If anybody would like to join, it's !Discord to request the link, to which then I will put it in chat. I do not have it posted anywhere on the channel. Anybody is welcome. You just have to follow the rules and ask to join. That's all. I'm going through my paces of anti-bot measures, and that was the best thing I could think to come up with. Is a simple, please, I would like to join, and then it will allow you to do the thing. So if anybody's curious, would like to join, you're welcome to. Just gonna ask. Speaking of which, in the description of my channel are all my commands, which this is a good time for me to check and see if these work. Like lurk and unlurk. Yay! Because I swear every time I turn on commands that the bot for some reason turns itself off. And then I'm like, why? What did you do? But good. Now, as long as those are working, that means that the one for the server will work as well. Which is the idea. Okay, so before I push any code, we're not gonna do it. We're not getting there yet, because I want us to be able to compare based on what we have right now before we touch day 29/30. And then from here, we are going to turn on some overhead lights so the camera can see what the heck we're doing here. And hook up our previous exercise so we can take a closer look at it. Now, this is one of those differences where there's no change in hardware, excuse me, in where the hardware is connected. This is solely a coding difference for the exercise for this week. So I'm going to go ahead and plug this in. We're going to let this fire up. And then where we left off, I'm going to zoom the camera in a little bit here so I can show you what we're up to here. Maybe. There we go. Okay. What we have is our lander display.
that we have right here. So what we have is the current state of the system, and we purposely have here our thrusters, our systems control, and confirmation. Below it is the status of the ship. We are in the initialized state because all the switches are in the on position, which means that we need to get into the ready state. So we need to turn all these off to be able to do that. So with everything in the off position, I pushed all these little switches down. We're now in pre-flight. So now to start the countdown and get our graphic on the lander here, we then turn all these switches on. Now, the only thing we have mapped on the keypad, which is this one right here, is the single button that allows us to move the landing gear up and down. That's where we left off with this. So I'm going to engage everything here. And then that shows our little ship. And then I have to remember which button it was. I want to say it was S4. Yep. Switch number 4 causes the landing gear to go up and down. Or maybe just down. Which one of these was up? I don't remember. Oh, there you go. So switch number 4 puts the gear down, and switch number 8 directly below it puts the gear back up again. So this is the quote-unquote animation we have using the bitmaps that we have. So there's a bitmap that makes the ship look like the ship, and then there's 2 additional bitmaps. Actually, there's only one other bitmap, is the landing gear. No, I guess technically there is 3 bitmaps, because there's one of it being almost up, and then the third frame would be it just disappearing. Yeah, it goes down, and then at least 1 or 2 frames back up. I don't remember how many it was. I only know it was a couple frames that make up the actual animation itself. And these are all bitmaps. So I didn't copy an image file. It's all that code that's broken down into a visual as to how we got where we are. So before we do anything with the new code, I wanted to showcase where we are. So I'm going to zoom our camera back out here. And then we're going to dive into the code we have for today. And as it stands right now, I can put all these switches back in the off position. And the code has no way to determine to get out of the loop that shows this graphic by the way that day 28 was written. Which is why you'll notice that when I shut all the switches off, we're still looking at the lander. And I can move the gear up and down because the code has no abort sequence. That was part of one of the things that day 29 brings to us. So let's get into that.
Okay, congratulations, Explorer. Today is your day, hopefully, where you rejoin the mothership. Now, space is big and your docking bay is very small. Today we will add our thrusters and steering into your controls so that you can initiate your final burn to the mothership and control the approach to successfully enter the docking bay for a successful landing. You will first need to ensure that our control panel is in a known state by turning off all the control switches. Once that is complete, you will enable each system in turn by switching all 3 switches in the on position. Then the display will change to our approach/landing display. The current speed of the lander is displayed in the upper right hand corner of the left side to display our targeted radar. The distance to the mothership is shown on our 4-digit display. The closer you get, the lower the number. We will use our button matrix to control our steering thrusters, and here's the mapping as far as it goes for which button means which thing on here. Once you see the radar display, you can begin to add thrusts using the +T button. As the speed of our lander increases, you will see the distance to our mothership decrease. If the mothership drifts off center, you will see arrows appear on the outside of the display to indicate which steering thruster to fire. Just press the appropriate button until the arrows disappear to keep the mothership centered. Remember, to give yourself enough time to reduce your speed, you must land within 2 or less for a safe landing, or we're just going to end up crashing into the bay. Lovely. Keep the mothership centered, speed low, and landing gear down to safely go into the ship. The original plan was for us to add our rotary encoder to our design to control the thrusters, but as sometimes happens when working with complex devices, our plans need to change. It turns out that there is some type of conflict that prevents our rotary encoder from working correctly when it's added to the switches, OLED display, and 4-digit counter. However, we have unused buttons on the matrix, so we'll use those to control the thrust, which is how we ended up having thrust up and thrust down, which are these two right here. Because in the video, it mentions that we were going to use the spinny bit, the encoder, but we don't have that for today. Okay, so since that means, right, because there's ending bitmap, no gear. Let's see what kind of bitmaps we have here by name. We've got the success fit bitmap, the ending bitmap, the too fast, they missed the mothership. So either the success or failure. The radar arrows make more sense now as to these bitmaps being what they are, which is exciting. And then the small landing gear doing what it does, which is fair enough. Yeah, landing gear 4, landing gear 3, 2, and 1. So that's the 4 frames that make up the landing gear. And that's something that I'm pretty sure is the same as last time. But it's just kind of where we ended up, which is fine. Okay, so we're going to wander through this at a slightly elevated pace so that we can go through what is here. Because our main code is quite large. We've got just shy of 700 lines of stuff. We're not going through this line by line. I know, I do realize a lot of this is comments, which is fine. I'm actually going to take a quick second and print out for myself the directional stuff. So be right back while I go grab that. Okay, so now we have a paper copy of those controls right there that tells me which button does which thing, and that is just something that'll help me out a bit, which is good. I'm starting to wonder. I'm starting to wonder if the I can't do that because the device is occupied. Oh no, it's not. Okay. Okay. I was wondering if the virtual camera was zoomed in. That's fine. All right, nor here nor there. Okay, so same thing as before. We have our Arduino class, which we need to interact with the board. And then we have our libraries that I've spoke at length before, which is going to allow us to use the connected hardware. These includes are fairly new to us. These are the ones that make up these additional files that I have here at the top of the screen that are own separate tabs. This include is what allows us to access this code with it being in a separate file. Now, I do mean it is indeed a separate file, because if I go into the file system here and we take a peek at the day, here they are. They are separate documents that live in the root folder. So day 29/30 just knows they're in here with them. And then that's how it gets to them. Alright, so let's see here. So it says, create an array of pointers to each of the bitmap images. For a smoother animation, you could simply add additional bitmaps into the sequence below, and the code would automatically adjust. Which makes reasonable sense, because individual frames is what makes up an animation. And that's exactly what we're doing here. We're using 4 static images shown in an appropriate order and speed to make the graphic of the gear going up and down. So that means the gear up is 1, the gear in the process of going down is split across 2 different images, and then gear down is it fully deployed in the down position. So up is middle, and then partial, and then it's all the way up. And then you just run those images in reverse to go the other way. Out of curiosity, yeah, at least these still work, even though my mouth doesn't want to move. I am the ventriloquist toaster. It's not going to stop me. We're going to get through this. I don't care if my tracking is going to be wonky. Ain't stopping me. It's going to mess up my VOD, but whatever. It's fine. Alright, so calculate how many gear bitmaps we have by dividing the total size of the array by the size of a single item in the array. I still don't know why we're doing this. Why don't we just count the amount of bitmaps? Why are we getting the size to figure this out? I still don't understand why we're doing this. And I've watched the explanation, and there isn't really much, rhyme or reason. I don't know. I know a decent amount, but that's not the way I would go about finding a count. I just don't know of a better way to do it. So we're just gonna leave it the way it is. Okay, so then the gear states will define values used to change the bitmap index. So we have gear idle at 0, means the landing gear is just in its current position. That could be up or down or somewhere in between, frankly. These are all binary, or technically, integer, not binary. So we're either in the state that we're currently in, we're either dropping the gear down or pulling it back up again. And the idle state is technically condensed with the landing gear retracted, because in the lowered state would be 1. And then to bring it back up is a -1 to bring us back to 0, which is our quote-unquote idle state, which is fine. And these enumerators are just words we've used to give meaning to these numbers. These are the 3 different states we're in, but we give it the meaning. That's the tricky thing with this. You could definitely write this to do exactly what we have on the bench right now, but we can make it look super ugly and not make any sense to us, and that wouldn't be any good. Which is why it's good to write not only code that you can read, but also wander through code that you can understand next time, which is why comments are so important. Alright, so then we're going to get our hardware. We have our 7-segment display and the respective pins it's on. Our dip switches are in analog pins, which we normally don't do over the course of what we've done, but apparently that's cross-compatible. We needed just about all the pins to plug in the keypad, so that was our way around it. And then we do our definition for our keypad. Now I know this is different than last time because we didn't need the last row. That did change. We do need it now. So we have a definition for all 8 pins that controls the column and the row. The keypad library isn't restricted to just returning numbers or letters. Since we will be using the button matrix to control our lander, we defined an enumerator with our commands and then set up the buttons to return those values. That's excellent. Okay, well that actually makes things kind of nice for figuring this out. I thought we were going to end up using some kind of generic stuff. I didn't know we could just use an enumerator. That's actually really cool. Steer down is 2, steer left. Can I see the value? You did it for the other ones. Values 3, 4. Right, so this is just counting, and unused is 0 or 1. What are you unused? You're 0. All right, so we do start our count at 0, but we're not using it, so fair enough. And that's all the way down to lower speed, which is value number 12 out of the 16 keys we have. And then define our button array using constants to be returned for each button. So then we take our enumerations and then we just this is where we defined the size of the keypad, which is a 4x4, and then which thing is tied to which button. So this is where we tie our enumerator, which all it does is it returns a value. It's a simple number. So it returns a 3, which means steer left. But instead of having to remember which number meant which thing, we can just use the words, which is why enumerators are so much nicer for basic tasks like this. It gives additional meaning, but it also makes it much easier for us to understand, which is appreciated. I'm going to take a really quick second and restart my VTuber. That is genuinely going to drive me crazy. I'm going to keep talking while I'm waiting for the camera to restart to see if I can fix the face tracking while we still keep going here. So I'm going to keep going. I will hopefully reappear here in a couple minutes. Okay, so with that, we then have our keypad lander controls. So what is this? This is create the lander button control object, which is the row pins, the column pins. All right, and then we've got better. Oh yeah, that's better. Yeah, I need to restart the camera service. Okay, good. All right, good. I like having a moving mouth. Yeah, create a lander buttons object. So, okay, all right, right. So to use the keypad, we have to create the object, the keypad object, and we have to name it. So since we're using it to control our lander, we've called it lander_controls. And then from there, we could see here that we defined control buttons based on the chars. Now, if I hover over this, you can actually see what they're defined to, and their values, which are just simple numbers. But the numbers are tied to the special names that we had. And this whole thing, as I mentioned, using an enumerator, will just assign a simple number in order. It's never out of order from what I can tell. And then we have our approach stage. Now we have some new ones. right? So we have the initial state and pre-flight, which we had before. The two new ones that we picked up today is the approach in flight and approach final. Begin the approach of the mothership and then lower the landing gear on the final approach. Now, it did mention there's going to be some randomness to the code, so I'm imagining we're going to end up seeing something along the lines of a random function, which in computers, there is truly no random with computers. It's all seeded based on some basic static math, or feeding it something that's semi-random, like the clock on your computer. The time is constantly changing all throughout the course of the machine running, but by the way that computers work, there is no true random when it comes to the machines figuring it out by themselves, which is why, fun fact, if you I highly recommend you look into this. Cloudflare uses lava lamps to generate cryptography ciphers for, I believe, certificates, if I remember correctly. They use the randomness of the lava lamps to help build security ciphers, because the randomness in the motion of the lava lamp apparently is never the same in the way that it takes its path. Kind of like there used to be an old program, I can't remember the name of it, but a part of building the security cipher to encrypt your password and salt it and hash it, you had to actually take your cursor on the screen and randomly move it in the little box, and it would use the random movements of your mouse to secure and generate a unique and random salted hash for your password. And it truly was random because you can move the mouse however you wanted, and the theory there is that two users are going to do it exactly the same, so it'd be very difficult to reverse engineer that. And the other thing too is that salted hashes are generally one direction, without having the key in combination with the raw data to run it through the same process will then allow you to spit out the same answer to compare the two together. Because the idea of at least what I used to, I am getting so off topic. What I used to do in college, I had a class where I had to make a salted password hash, and what I ended up doing is I took the process to take the data and generate a hash, and as long as I always provided it the same data, it could always rehash it and then get the same thing. But by using something to randomly generate the security of this, then you need to store that randomness somewhere. How that ties into all this, computers aren't generally random. So I'm curious to see what we'll have, whether we'll just have a hard-coded seeded value, which means that just you use this random quote-unquote number that's the same every time to generate our tilt or whatever it is going to be to make us go back to the mothership. Yeah, that's a random, but it'll look kind of random. I don't know, it's funky. All right, let me see here. Constant initial distance. Okay, so the ship will always be the distance of 1,394 at the beginning of the code. This is truly just a guided example, so sure, why not? It has to be coded to something. Could it have been random? Absolutely. Does it need to be? No, not so much. All right. Maximum size of the mothership docking bay. Initial display of mothership is small dot. Why are we applying? I have been broken for most of this stream. Hi, Satanic. Welcome on in. I haven't seen you in literally forever. I hope you're doing well. I'm doing the best I can. The stream has been a hot mess. I got my tracking back, so I'm happy. Where am I at here? Yeah, maximum size of the docking bay. Mothership is a small dot, but expands to the size as we approach. Oh, cool. So the dot's going to get bigger the closer we get to the ship, which is cool beans. I like that. Odd numbers used to make it easy to center. Same size to either side of the maximum, which is fun. It's been a wacky and rough few months. Yeah, no, that's fair. Well, I hope you're doing okay. It's life can be tough like that. for putting it politely, which would stay within the confines of Twitch TOS. Naturally, we all have some choice words for life, which I can't say here. But nor here nor there. Alrighty, so our void setup is going to involve the things we need to do first. Alright, so let's see what we're up to here. Oh, good. I'm glad to hear you're doing better. That's good. It's good. That's the right direction. All right, let's see here. So we turn on the serial monitor, which is fine. We use random numbers to move the target mothership randomly. In order to get different random numbers each time we use this function, which reads from our unconnected analog pin, which is floating, and thus will return different numbers. Interesting. Okay, that's a fascinating way to pull random values. Okay, so that's kind of blowing my mind a little bit, right? Because the whole theory here is that computers don't like to be very random. They're very not random in nature, but getting a reading off of an analog pin with nothing connected and no path to ground is going to read some kind of number. It's probably not going to be truly random. It's not probably going to be significantly different every time, but that's probably pretty random. That's cool. I like to see how that's how they did that. I don't know if it feels kosher to want to do it that way, but that's an interesting way to go about it. Oh yeah, I saw that you lost your pupper. That's never good. Sorry for the loss there. That's hard. Losing a pet's hard, especially when they're your best friend as a service pupper. Okay, yeah, so we've seen this before. We're going to configure the OLED display. This is all the same stuff that we used to turn on the lander. And then we choose our font pack, which I don't remember if that's the same as last time, but we'll see what it looks like. Nothing too crazy. Oh, I'm glad to hear that. Something to make the day a little brighter. Okay, so we're going to configure our lander. We're leaving it on maximum brightness. Yes, we are turning it all the way up. That'll be okay. And then our same pins for the lever system. And then, okay, so now we finally hit our loop for the code. And let's see here. So time thrusters are first fired will be 0. Gear max index. Image of the lander with the gear up, which makes sense. Approach state. Initial approach state is going to be set to initialization or init. And then the gear state will be idle, which means it's in the it's collapsed, it's up. And the initial distance will be what we set up above. Now granted, in a real world scenario where we were actually be floating through space, on the beginning of our code we would want to check the state to make sure that the gear is fully retracted. We wouldn't want to just simply tell the computer that the gear is retracted if the gear is down, which is when it would involve additional sensors to check the physical state of the equipment to actually set this. We don't have any physical equipment hooked up to any particular expanded legs on a spacecraft, because this is, well, an example, but that would be something that would be different. In a practical example, we would want to check those to make sure that we know the position that these things are in, because it would be very bad to blindly assume one thing or the other. We wouldn't want to assume the landing gear's down when it's not, because that would cause us to crash into the ship, and we wouldn't want to try to retract or to deploy the landing gear when it's already down, because if you know anything about motors, all of them have a particular limit, and I'm sure that landing gear in this particular instance would probably use something along the lines of what's called a gear worm, which would tell it to keep spinning beyond the maximum path, and well, probably would destroy the landing gear further to the point that the internal mechanism would die, which would be bad because then the landing gear would go up or down. Yes, exactly. Crashing is fun. See, there's this thing. There's landing. Taking off is not the problem. It's landing is where they get you, because you got to come back down and hopefully be in one piece to be able to do it again. Oh God, I could hear that. Terrain, pull up, pull up. Terrain, pull up, pull up. Yeah, we gotta be careful with that. That's that. Oh my God, I could think of a particular flying fox right now. Flyby fox. Yes, I probably that's probably scary to hear those words. As a foxo that is in the process of, I don't know if there still are. As a foxo that's been in a plane, actually flown a plane. I have not. I am a toaster. I am flying only by how far you could throw me. That's about as far as we're going to get to that. But oh, the stall alarm. Yeah, exactly. But yeah, in a real world scenario, we check actual system data. All right, and then we're going to use switching statements. I love switching statements. I wish we saw more of these, but again, it's a beginner's kit, so I get it, but I kind of like it. All right, so we read our approach state based on what's actually happening. So the case of approach is initialize, which was initially set here at the top of the code. So when we first start the code, our approach state is equal to approach underscore init, which means that the first go around, we always run this code. And then as we check additional cases, we then use this case to change the situation we're set to be able to wander through the other cases that are potential in our stuff here. So we already know that we have to have all the switches off and then turn them all on to set ourselves into pre-flight. We saw that last week, well, technically 2 weeks ago. Last time we did this is when we saw that. And then the case of pre-flight is when we have enabled the thrusters and everything is ready to go. And then the next couple of things here, it looks like they're a little out of order. The approach final state, lower the gear, we're about to land. Check to see if a gear change button is pressed. Do not wait for a key. Interesting. Why is there nothing in this? In flight state, add thruster to move closer to the ship. Remember, you have to reduce thrust as you get closer. Case approach in flight. Interesting. Approach final. Check to see if the gears button is pressed. I don't understand why there's nothing to do here though. These are all comments, which means that under the case of the final approach, this does nothing. I wonder if that was intentional. Huh. Well, approach in flight. Let's see what this does. Looks like we have some nested, another switching statement, which is going to involve the buttons and I'm sure the arrows that like make this be, you know, what the exercise is going to be. So the case of raise speed, lander speed plus increase our speed to go faster. If this is the first time increasing speed, then save the start time. Otherwise, we've got nothing. Yeah, final approach code, quote unquote, just guess. Yeah, that's kind of what it feels like. I am very confused as to why this is literally all comments. It almost feels like they forgot to write something in here. Yeah, no, code then drops into in-flight state. Oh, I guess that's why. Well, that breaks there, right? Approach state drops into in-flight state, which is not that one. Where's in-flight? Lander distance. I'm going to find this because this is going to bother me. That's pre-flight. I want in-flight. Where the heck is in-flight? Are you hiding down here somewhere? The nice thing is if you highlight code and you're looking for another copy of exactly the same thing, no, I don't know where the heck that is. I could control F it, which I might have to. In-flight display, including final approach. Let's display in-flight. Huh. Yeah, there's gonna be a lot of code to wade through here. Oh yeah, no, you're good, Satanic. By all means, I mean you can lurk all you want, or if you gotta go do other things, by all means, please do the thing. I'm just gonna sit here melting my brain, and anybody else who decides to pop in and to watch, that's totally okay. You can do what you gotta do. Because I really want to build a Protogen head, and I really think Arduino is going to be the way to go. So the more of this I can understand, the better. I can admit though, this is definitely an interesting exercise we're going to wander through. So there's our control button press. So then we're reading what happens here. The keypad library only returns a button value when it is initially pressed. Wish to continue to get the same value for as long as the button is pressed. This function keeps track of the last button pressed and returns it until the button is released or another button is pressed further. I know you, in fact, you have additional brain cells in that can of yours. We all do. It's just, you know, what? Now listen. We all come across people who have brain cells that are social distancing to this day. But I know you're not one of them. You're a smart cookie. All right, let's see here. Someone said that to me earlier in the week. I thought that's absolutely fantastic. That, and also the other phrasing of Linux is the Dark Souls of the operating system world, and I absolutely love that phrasing so much. I know nothing. I'm a tester on the internet. Wink, wink, nudge, nudge, blink, blink. It's fine. Alright, let me see where I'm at here. Blah, 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 blah. Alright, so yeah, this is going to be the code for increasing speed and then lowering speed. Lower speed unless stopped, because we can't go slower than nothing, which makes a reasonable sense. If the lander is less than 0, then... If lander is less than 0, lander speed minus minus. Right, so another thing too is that the whole minus minus or plus plus, in just about any language I've come across, that means that you add 1 or subtract 1 in that order. The double minus is to subtract a single digit, and plus plus is to add 1. That is a simple way to just add math without having to actually, you know, write it out. It's like a notation. Oh yeah. Aww, that's adorable. I love that. I'm glad you had fun with that. I got some really positive feedback with that, and I definitely plan on doing it again because it was fun. It's a good way to make those smile, including myself. It's fun. Alright, so we got that. Lower gear. Let's see where we're at here. Alright, so we want to lower the gear unless it's already down. We don't want to be more down. That would be bad. That sounds like a good way to break stuff. Right, so that's the same as last time. Raise gear, that's the same as last time. Alright, so we got some new stuff here. So this is the actual code for steering the ship. So our mothership Y offset plus plus, steer the lander 1 pixel up. We are literally moving in pixels. And the plus plus and minus minus again is in 1, which means that we are going to move 1 pixel in the direction that you choose. I'm glad you loved it. I had a lot of fun putting that together. I got some ideas for this year too. I I have to I'm gonna have to spend some actual time to actually put that together, because the idea I have is going to be fun, and it's going to be fun to do, but it is going to require some effort on my part. But that's never stopped me before. I promise you that. Yes, the banjos. Yeah. I've been in those parts of this country. Damn much. That's interesting. All right, so yeah, that's gonna wander us through that, and then we have some. I'm gonna refer to these as strafing, where we're steering up and right and up and left. In video games, it's a strife when you're moving at a diagonal, which is fine. It's just what we're doing, and then it's just, you know, 1 pixel per direction, so up and to the right, up and to the left, so on and so forth. And then same thing for down. So that's pretty self-explanatory. Here we compute the drift of the mothership using random numbers. The mothership cannot drift off the display, done by setting a maximum drift. That's probably a good idea, because if it floats off the screen, then we're gonna have trouble getting it a lock back on it. So our maximum drift is 18. Interestingly enough, I wonder how we came to that, because the screen in pixels is 200 by 64. 200 across and 64 pixels up and down. I don't know where 18 comes from, but fair enough. It'll keep us in frame. I'm sure that we're probably using a portion of the screen once we get this uploaded. I bet you that's probably what this is about, so that it keeps things within frame, which would actually make decent sense. All right, so then we're going to use our get random. Okay, so we're actually using a get random function. Now, I bet you that's based on, that's definitely a function we have written in the code further down, so we'll find it. And then if the mothership drift x offset is maximum to the maximum drift, mothership is equal to maximum drift. So yeah, so if we are drifting beyond the maximum, we just set it to the maximum. So if we bump up near an edge, we just set it to 18, which keeps us on the screen, which is good. That's good. I'm glad we can't float off into space and not be able to find where we're going here. All right, so we're going to prepare for the landing on final approach. If the lander distance is less than the initial distance divided by 10, our approach state is then equal to approach final. On the final approach, enable gear and warn is what that's about. So because we specified our gear states as 0, 1, or -1, as we saw at the top, we can change bitmaps by simply adding the gear state to our current gear bitmap index. So our current gear bitmap index plus equals the gear state. Interesting. Well, if we take a look at our landing gear here, our landing gear, that's how that works. So it's landing gear underscore, and then there's the number 1, number 2, number 3, number 4. So apparently, is that how that works? Flips off laws of gravity, starts to float up. Wait, no, I was kidding. Oh, now that straight up sounds like an ASDF animation. I know exactly which one I'm thinking of. Also, I can't agree with Tomsky. He refers to it as the Acid series. I've only ever known it as the AFDS franchise, so my head can't see it any other way. Just like as if you're from like a small town and like the name of the town, you pronounce it a particular way, and then someone's like, that's not how you say that. I'm like, my guy, I've lived here for forever and always. This is what I'm going to call it. That's kind of the hill I find myself on. With that as it is. I can accept the fact that I'm not correct, but that doesn't mean I'm going to be able to say it correctly. It is the way of the toaster. I do my best. But enunciations and spelling, my guy, that is the hill I fall off of. No, I don't die on it or stay to be in my lane. I struggle. I struggle bus. Sometimes I'm on the struggle bus, sometimes the owner operator of the struggle bus. Depends on the day, to be honest. Hey, when it comes to enunciations, oh yeah, we're there. We are there, my guy. Oh, you're helping me hold the hill. Hold the hill. We have invaders. Yeah, it's grammar correction tools and spelling. It's the dictionary. It's coming for us. The thesaurus is going to be the spy, though. I could promise you that. Go sneak around the back. Makes me think of the orange box. I am getting hilariously off topic. Oh, it's fine. It's fine. I don't know what my arms are doing. I don't know. My tracking is still so angry. I am not rebooting. I at least got the camera working. Ugh. All right, that's fine. I'll reboot after broadcast. Well, it doesn't matter anymore. I'll reboot. All right. Blah blah blah. All right. So then a lot of this is gonna be the same as before, where we have our states. I will always admit that I'm pronouncing something incorrectly or referring to it as incorrectly, but I'll never accept that I'm wrong. Listen, I get it, okay? I truly understand. Been there, done that, proceeds on. I'm gonna break out of this case, because it's true. Alright, so this is the same as before. We check our lever states. Blah, blah, blah. We have the lander distances. Oh, here it is. The case of approach final. It was down here at code line 403. See, I knew we would bump back into it. And then we display final, so the current gear bitmap index. Pass as current gear bitmap index image of the lander with the gear in the up position. And then that's approaching flight. It's just that stuff. Lander distance is equal to the lander's minus the lander speed. Adjust the distance by the current speed. All right, now we're gonna get into some icky stuff here, I'm sure. End of flight. When we reach the mothership, distance is less than or equal to 0. Then determine the success or failure and display finally screen. Finally? Final. Fine. I don't like that. I don't think that doesn't look like it's spelled right. Hang on. I feel like that's supposed to be 2 L's. My brain is struggling with that word. I don't like that word. Yeah, it's missing an L. Finally, it's 2 L's. Get out of here. My spelling is terrible, and even that stands out to me. Much. All right. Our failure and display finally screen. Which said I don't like that. It's the final screen. Okay, I'm struggle bussing. Display the final screen alternating with the last radar image. So we should be able to go back and forth between the two. All right. And then let's see here. So our ending bitmap, what do we have here? This is a char and a star. Why do we have that? When we reach the mothership, I want to understand why we have the star next to that. Let me look that up. That's different, because normally when you declare a char, it's just char. Yeah, I don't like that. What does that mean? Char star means a pointer to a character, holding the address where a character is located. The value that pointer points to is a character. So this is a character pointer? Interesting. There'll never be a code of the CPU in my Cortex would just shut down. You know, I feel that, okay? Let me put it this way. I do this for fun, even though it sounds like my head's catching on fire. This would not be my daily job. It couldn't be. Something would combust in my being. I would need a lot of patience in a hurry, and I feel like I'm a fairly patient toaster as it goes. I don't know, a pointer object. All right. I'm not going to argue with it, but that's just a strange thing. All right, so if the landing gear is less than, we have that, the landing distance is 0, we hit the target. Now check the speed to see if we were slow enough to not bash into the building. So if the landing speed is less than 2, which is our maximum safe speed, is okay. We show the good bitmap. Oops, gear is up, damage to lander, but we survived. AKA, we crashed into the ship. Ending bitmap with no gear, and we're sad. Speed is too fast. Lander and mothership is destroyed. Oh, that's gonna be expensive to fix. Ending bitmap too fast. And then missed the mothership. No fuel for another try. by ending bitmap, missed the mothership. Interesting. So that's taking into account of whether we were too fast or too slow. And then the distance displayed, show the final distance in decimal, which is fine. Calculate the elapsed time in milliseconds from the first thrust. Elapsed time is then stored there. I wonder where we're going to spit that out. Format to fractional seconds using sprintf. Char buffer 20. Buffered long enough for final display line. Since elapsed time is a long integer, we can get the number of seconds by simply dividing by 1,000, and the fractional portion is dropped. The modular operator, ampersand, as it's referred to in this case, not percent, returns the remainder after dividing left side by the value on the right. This gives us the fractional number in seconds. Sprintf uses the LU to indicate that the value is an unsigned long. LU does not work. Sprintf uses the LU to indicate that the value is unsigned long. LU does not work. Interesting. So we're going to sprint the buffer. So the buffer is the name of the variable. So we have a char buffer that can hold up to, so it's an array of char. How can I even say this? This is an array variable called buffer, and it's got 20 positions 0 through 19. And what we're going to do with that is we're going to feed it this gobbledygook, and then take our elapsed time and then divide it by 1,000 for the seconds, and then divide it by the ampersand to get, and divide that by, so yeah, we're going to take the elapsed time and we're going to ampersand it to get the remainder by 1,000 of the fractional, which should be the milliseconds. I don't know what this is about though. This is just blowing my mind. Final display, alternate between splash screen with time in final radar view. I'm gonna be completely real with you. With this exercise, this lost me. I don't know what this is about. That will just simply need further research as to what on earth that means. Cause, yo, the toaster fell off. I fell off the counter. I don't know what that's about. You know, out of curiosity, real quick, if I throw this in Google, because I am kind of curious to see if that will give me anything that might explain what on earth that means. I don't know what that means. What do you mean? Oh, it's a formatting string. That's what it means. Okay, so all right, so this thing. Okay, I don't know why I should have recognized that. Okay, so this gobbledygook is formatting. So the percent for LU specifies the format and prints the second portion of the time. The percent symbol marks the beginning of a format specifier, and then the rest of that is just formatting what we're going to see. Okay, so this, the only way I could describe what this basically means, in Microsoft Word, you can choose to change the color of text and whether it's bolded or italicized or underlined, right? Those are formats, right? And those are visual formats. You can see those with your eyeballs. What this is the code that is going to apply our formatting. So our formatting, instead of being something that is easily understandable, it is a computer computational version of the formatting, which, without me Googling that, did not obviously tell me what that was all about. And that, I'm imagining, is a function of the sprint thing here, which indicates that we're going to see printf that sends the formatting characters into string. Okay, so this is gobbledygook that the function sprintf actually understands. And to us humans / toasters, it just looks like nonsense. But that means that the self-help for the sprintf function would have a breakdown of what all this is. In the world of Linux, there's a thing called the man pages, which is short for manual, which you could use on any command in a Linux terminal. You could just type man space the name of the command, enter, and it'll pull up the self-help that's built into the terminal for that command. Give it a try the next time you're trying to figure something out in Linux. It comes up incredibly helpful. Different terminals have different helps. PowerShell has one built in. It's just called help, which is convenient. I think Command Prompt has one, but I'm not sure what it is off the top of my head. I don't need it very often. But this is a perfect example of if you didn't know what that was, like I didn't. If Google didn't immediately give me an answer, my next clue would have been to look up the help pages for the function that it was stuffed into, to figure out what on earth it means. Which I'm glad I looked. I feel better now. Okay, so then we're then going to cycle through our bitmaps by going into the function where we're going to display the first page, and then we're going to draw what we put in the buffer, the lander, which bitmap, and then these should be positioning values because we're using the draw x bitmap. So 0, 10, and then the bitmap width, height, and then which bitmap it is. In this case, it's the ending bitmap. That one's hard coded into this chunk of the code. And then we just, while there's another page, once we've reached the end, we'll then delay for 2 full seconds and then keep going. To which then we'll swing down here. And then if do display final, if the current gear, or yeah, display final current gear bitmap. So we only fall into that. That's outside of that. Trying to figure out what that's nested inside of. End of flight. Okay, so this just happens because we've fallen out. There was no more. We're still in the main loop, but there was no more to keep us from falling into this code at the bottom. So that's why I can't find a container. It's technically outside of it. All right. While true, repeat this final display until hero is reset, never reached. This is our final execution of the loop. Delay 100 milliseconds or a tenth of a second. Update the layer display. Okay, so then these are our functions that we call upon. So the code we saw up top. So this ending brace right here at line 481. This ends the main loop. Any function that we design is going to be written outside of the main loop, which is why we have these functions that are down here below it. And this is what we call on. We can call on this as many times as we want in the main loop, but it allows us to condense our code into containers and then label them what they do. In this case, this one displays the pre-flight information by getting the state and the position of the thrusters. Excuse me, the position of the levers, or the 3 switches on our board. From there, we then do some wizardry to then draw the positioning of our switches to be on or off. This is an if statement. If it's true, we're on. If we're false, it's off. But this colon is a simplified version of an if statement. It's just condensed to save space. And then it stitches it together. So it says systems, a colon, and then the status. Which we did see that before. And then our status line, what do we have down here? In-flight display includes the final approach. Let's see here. The mothership initially appears to be a single dot, but expands into a rectangle as we get closer. Scaled based on the maximum width from 1 to max. Which is then going to do some math to get our mothership. Yeah, always at least a pixel in height, because you can't see it if it's smaller than a pixel, which makes reasonable sense. And and then we do some more math to just kind of generate something to play with. I don't really have much more to say than that. That's all it's doing. Display the bitmaps with 0 bitmaps set to transparent. This allows us to overlay our arrows over the radar circle cleanly. Interesting. But then again, display bitmaps with 0 bits set to transparency. Lighter display set bitmap mode to 1. Our arrows over the radar circle. Draw the radar display circle and center pointer dot. Alright. As the mothership's radar returns drift on the screen, this section of the code will display an arrow on the outside of the radar circle. The first constants can be changed so that the arrows don't appear until the target pointer is outside the lander's bay box, but currently the arrows appear after a small amount of drift. The coordinates for the arrows were originally generated by ChatGPT. Fancy that! And then individually tweaked for perfect location. Because of this, the coordinates will need to be manually adjusted if the radius of the circle is changed. So they literally use ChatGPT to write some of this. Isn't that something? Drift before arrow is set to 2. Drift before Y is set to 2. Outer set of if-else statement checks for left-right drift. And then we pull which arrows to draw based on the drift. That's what I'm getting here. That's what all these if statements do. We'll use the sprint F to format the lander speed line, which again, there's another formatting string. And narrow draw the image of the mothership as a rectangle. Size based on the distance and offset of the XY coordinates of where the ship is from the center, which is a little bit more math. Lander but to land. We have to make sure the gear is down. If not, we're going to crash. All right, now these helper functions were here last time. Lift off state to string, which allows us to just change our state into visible text that's on the display. So our approach underscore init, we can't print that because that's the name of the variable, but if we then can tell the function what to write by checking if the case is approach initiate, then we spit out init, and if it's approach pre-flight, then we literally say pre-flight. That's a way to take a state and turn it into something visual we can see. Well, that's why it's called a helper function, because it helps us visualize what we're doing. And then we got the lander controls. The keypad library only returns a button value when it's initially pressed. We wish to continue to get the same value for as long as the button is pressed. This function keeps track of the last button pressed and returns it until the button is released or another button is pressed. So lander controls, static char, last key is equal to no key. Current key is the lander gear, get keys. New key seen, save the last. That's where you override it. If the button is released, reset it to no key. Okay. Current key, button still pressed, so return last button seen. Alright, and then there's the drift control. Must be greater than 1. Higher numbers slow the drift rate, which we're set to 3. Okay, so we have our integer, which gets our random drift. This is another one of our functions that adds a little bit of wonkiness to this. Oh, howdy, Pine, welcome on in. Random low / high returns a random number from low to 1 less than high. We use -1, 0, and 1 for the drift. To slow the drift, we can increase the number of values that indicate no drift by generating numbers higher than 1. If the random number is higher, we set the drift to 0. With the drift control of 3, we get random numbers between -1, 0, 1, and 2. If 2, we change to 0. doubling the times we get no drift. And then we run that through random function, which again is only as random as it kind of feels like being. And that's all the code. So it's a lot to go through. That's a lot. And to get it all at once like this, I can admit I'm having a little trouble following some of it. The grand scheme of things, I get what's happening with it, but if I was asked to troubleshoot something that wasn't working within it, I know I would struggle a little bit with this because of so much that's going on. So in the grand scheme of things, if I came across a position where I was trying to figure out how something wasn't working in this code, I would break this down into its separate sections and give myself a tester variable, like a test variable, to wander through the different potential paths you can end up going down, like all the switches being in the on position, right? That's a state. One of them being on and the other two being off, that's another state, right? These are different possibilities that the code can be in. And taking the time to go through all the different possible combinations tests all the code and also can help you debug if you run into a problem. But taking it into the chunks of the smaller little functions and like watching yourself get there, not only helps you write this kind of stuff, but also helps you troubleshoot it if you run into a problem. Because to try to troubleshoot 700 lines of code would be a miserable time if you didn't break it into smaller pieces to then object orient yourself through it. That's why this entire language is called object oriented, because you run through the separate little objects that you use to build the Legos to make the thing you're working on. It's the same concept. And that's kind of where we ended up. So I've said enough words. We're going to swing over to the bench, upload the code, and we're going to attempt to land the ship. I have everything else that should be prepped here. So let me switch this to the bench camera, and I'm going to click the verify button and upload. And then I'll adjust the camera so we can see what's going on here. Just a moment while this compiles. As it's taking its sweet time. Alright, cool. Then I'm going to upload it. Okay, so we're uploaded, and now I'm going to get over there. We're going to figure it out. Alright, so first things first, we need to bring the camera in. Like so. At least a little bit anyway. Okay, so I think we have a problem, because I'm pretty sure we're supposed to have something on this display right now. Or maybe we'll try it. I don't know if we get anything on the display that's out of frame. We have nothing on this display right now, but I think once we get the switches engaged, I think that's when we get something on here, but we'll see. I'll double check the diagram if we don't get anything. But first things first, we are going to get the ship ready, and then we're going to hopefully see this whole grid thing. So we're going to enable the thrusters, the system, and everything else. Okay, so now we have a dot that indicates where we are, and we have some drift, and oh, look at that, we have an arrow indicating where we need to go. And on my paper here, I have our controls. So I'm going to use this to my advantage, and we're going to go up. We need to increase speed.
All right, so I clicked. Actually, hang on. Let me zoom the camera back out here. I zoomed it in. This is gonna be a little hard. It's kind of small, but it's kind of big. So I'm using the directional keys, and we're going to position ourselves towards the dot. And right now, we're going to travel to our right. So that's going to be this button, and then we're going to go up. Then we're going to go left. We're going to go right. And then up again. I'm convinced we have a mistake here because we should be seeing something here at this point. Because we're supposed to have a clue as to how close we are from our destination. So let me double check the wiring diagram and make sure that I have that display in the right place. Because right now we're literally flying blind because I don't know how far away the mothership is, and we should have some concept of how far away we are. And that's not particularly great. Oh, howdy, Panic. Welcome on in. We're troubleshooting. Oh, look at that. We got a box, which means we're approaching the ship, but we also can't see how far away we are. It's okay. Well, we'll get that figured out here in a minute. We got to check our wiring first to see what's going on, because I think either something is loose or it's not mapped to the right place. So that's okay. We're going to figure that out. So let me see here. So right now we have got a lovely wiring diagram that I'm going to pull back up here while I have all you checking out the camera. Alright, so I'm supposed to be plugged into pins, let's see, 0, 1, 2, 3, 4, and 5. 4 and 5 is where I'm supposed to be. Am I actually in 4 and 5? I am in 0, 1. No, no, I am not. Interesting. So those pins were moved in day 29. Oh, you know what? I bet you that's changed because of where the rotary encoder was supposed to be. So I glossed over that. Yes, the toaster has fingers, you're correct. Yes, and also the toaster is a friendly reminder, spread kindness. We need more of this stuff in the world, I'll tell you that right now. Oh, drop gear. That's okay. We'll just crash into some stuff. It's okay. I have to unplug this actually anyway because I gotta move the leads. All right, so I said 4 and 5. The clock pin is the top one. The clock pin is the brown wire, which means I should just be able to move these up. So 0, 1, 2, 3, 4, and 5. So I literally should just be able to pick these two up and move them up to that position. So I just move them up to on here, and then I'm going to plug this back in, and then we'll get into the initialize step by going down, pre-flight, we're going up. Ha! Look at that. It helps to plug stuff in the right places. Okay. All right. That's more like it. I see numbers on the pretty display now. Cool. All right, so I'm going to attempt to route this in a way that we can see it and also have it kind of in a better position here so that I can show what I'm up to here. That's okay. I'm going to use my HDMI cable to keep the thing from moving around too much here. Excellent. I have it in frame. Oh, I'm sorry to hear that, Panic. Oh, there's nothing worse than passing out and then waking up in the middle of the night, and not only do you not know where you are, you don't know who you are. That's the bad kind of sleep. I've certainly been there before. Not fun. Okay, so now that we have how far away our ship is, we're going to use our directional map here to follow along where we're going. So first things first, we need some speed to be able to go forwards. So we're going to trim up by clicking the T+. We gain some speed. All right, so I'm moving at a speed of 2. We want to go to the left. So I'm going to hit, and then we're going to go left and down, which is going to be this button. and then left again, and then straight down, which is going to be that button, which I am trying to showcase and keep it in frame. Here, let me zoom this out a little bit more. There we go. I know it's so tiny. It's a little hard to show both. All right, then we're gonna go right, and then we're gonna go right again, and down into the right with our strafe button. And then inside of our radar, the box is getting bigger, so down and to the left. And then we're gonna go straight down. And we're gonna go up. I love how this is like sending me all over the keypad. Oh, we're starting to close in on it. All right, so let's reduce our speed by 1 because we're 800 units from the ship, and then we're gonna go up, and we're gonna go up and to the right, up and to the right, up and to the right, and then up and to the right. We're gonna go right, and to the right, right. We're going so right. I'm gonna make a circle. Yeah, we're getting closer. Come on, there is no way. I need to keep going that way. Up and right. Oh, now we're going down. Down into the right. I don't know where I got my pilot's license. It was probably on eBay. I'm not sorry. We're making an attempt. Down into the left. That's button S5 and S5 and left. That's switch number 5. And we're turning, and we're getting there. So the goal is to get the box in the center of the dot, is from what my understanding is. That means that we're going to be okay. We're moving at a speed of 1, so I'm definitely not going to approach too fast. I wonder at some point, probably we should put the landing gear down. I'm not worried. It's fine. I'm definitely going to crash into something. Oh, hang on, that's the wrong button. Down to the left, down to the left, down to the left, down to the left. Oh, let's get that box back in the middle, please. Oh, all right. We're drifting to the right now. All right, we haven't hit anything yet. My landing gear is still not down yet, and we're almost there. I'm sure it'll be okay, right? Hope. Up, right, oh god. I hit the keypad's turned on me here. Alright, then we want up, drop gear down, whoop. Ah, look at that! Alright, my gear's down. Gear is okay. Good. I would like to be. Oh, we're almost there. We're closing in on it. We're almost there. Got a little bit of random drift here, but I think we're okay. 5, 4, 3, 2, 1, 0. Shabam! We got a winner. Fancy that. I didn't hit anything, and I made sure to put the legs down. That's a really cool animation, though. I like that. So this is the winner bitmap that we pulled over from our code. So if I bring this a little closer here so you can actually see it. that's an awfully fun little thing. And just like that, then as it had mentioned, it says that we're not supposed to be able to break out. So if I tell it to pull the gear up right now, nothing should happen. Right. Nothing is going to happen because we're stuck in the ending loop now. And that's mighty fine. So yeah. Heck yeah.
So yeah, that is the remainder of day 29. Now, the reason that I have day 29 and 30 together is because day 30 is more of a wrap up. So we're gonna swing over to there. I'm gonna let the creators of the kit do their little bit of talking on their piece, and then I'll add my wrap up, and then that will close this little adventure out. So we are going to swing ourselves down to the bottom here. We're going to complete day 29, and that is going to position us for the day 30 wrap up. Captain Tech, another happy landing. Much excellence.
Job well done, Explorer. I never doubted you for a moment.
Now, there's a lot that goes into making, this.
Hey everybody, my name's Alex. You might know me from the code explanations throughout the
Indeed.
course.
Alex, I've
I want to
skipped you over many
congratulate you
times.
on making it through the 30-day Lost in
I gotta
Space
let him talk.
challenge. But your journey does not end here. Luckily, there's still more for you to do if you so want to. I would say, if anything, your journey has just begun. So, to give you a quick history on the 30 Days Lost in Space Challenge, this originally was a project that started back in 2020 with just me, and I had a little astronaut suit and a green screen in Austin's apartment back when we were very, very first young starting this inventor company.
Fair.
All right, so welcome back. Again, this is day 25.
See, we didn't see this
and
when I picked
like
up the
every
kit.
fifth day of the 30-day challenge, we're gonna give you guys that creative outlet once again. And we got a lot of feedback from you guys, both critical and good. And we took that feedback and then came up with a revision back in 2021. And we had our wonderful man, Greg, who you might recognize, was the person in this version of the videos who did all the wiring, but in the previous version, he was kind of the Astrid, the entire character cast for the entire thing back in 2021. And he is a man, the myth, the legend, and I love him to death. And thank you so much, Greg. I appreciate you.
I am a pre-recorded AI who will attempt to give you all the information
We watched a
necessary
little bit of
for
him
your success.
for when he would go through
This
the wiring
version,
example.
we had obviously the code improvements and the wiring obviously was Greg's focus, but then we also got a little bit more energy with Astrid. So I want to give credit to the actor for that because she did a wonderful, wonderful job playing in
Astrid is the one we saw
Space.
in all of our
So
exercises.
after about 3 years of a total amount of feedback we were able to get, and over 100,000 members in our Facebook community now that we've grown, we have grown to an insane number, and it's wonderful. We finally came up with the revision that you guys have just completed now. So we hope you've enjoyed, and obviously we look forward to seeing you guys hopefully joining us for what's next. So what is next? Well, first of all, if you haven't joined the Facebook group, join it. Like I said, we have over, it was 100,000 members plus at the time of recording the video. There's a chance when you join now, it'll be 500,000 plus. I have no idea what it's going to be when you join. Some large amount of number, probably, because we're just growing like crazy and we love it. In there, we have weekly events, we have giveaways, so maybe a chance to win something. Don't get your hopes up too much.
Love that.
But we do have some weekly events that we like to do, live streams, etc. we try to put on. We have a lot of technical help, so if you are building out something on your own and want a little bit of help, the members in there are always super easy and wonderful to help, and that's one of the greatest things in the whole world. Project inspiration, I've seen a lot of people post their projects that have inspired them. So if you are looking for project inspiration for yourself, it's a good place to go check.
Already
and if
have
you want
one.
something more advanced,
Love
I
it.
highly recommend checking out. We have another adventure kit after this, the Adventure Kit 2. Or if you're looking into the world of sensors and interacting with the outside world, I recommend the 37-in-1 sensor kit.
Okay, so something for this toaster. I checked to see if the Adventure Kit 2 was available for purchase because I looked and there is a literal boatload of different sensors and other things that were available with the kit that is currently out of stock. I would like to pick that up at some point, but as it stands right now, nobody has it in inventory. Looks like they had some kind of flash sale and they sold off what they had. So I'm going to keep an eye on that and see when that becomes available. Thankfully though, the 31-in-1 sensor kit though was available. This is an expansion kit that we can use with the Arduino board that I already have here with us in the studio. That's what we're gonna continue to mix in with everything else. I still want to do Arduino things, and this is a boatload of different sensors, and thankfully there are guided examples that go with the sensor kit. It's not just hardware. There's more silly things to do with it. Now, granted, I don't think it's as structured as this, like it's not going to be tied around like a space adventure per se, but it's going to be a guided example explaining how to use the sensor. In the fact that I still want to make my own custom stuff, this is awesome because this widens my own perspective understanding of what's available and how to use it in a guided fashion. I'm gonna let this finish the rest of its piece here, yeah, as it's rolling here. So we got a couple minutes left here.
Or if you want something that works really well with your Hero board right now, just a quick pop-on device, maybe a slightly more beginner, you can check out our Shields kit. Finally, if you want some more projects with the parts that you already have, we do have an InventU catalog with a repo of a lot of our old weekly live streams that we're starting to build up. The first of which will all be using parts that you already have available in your adventure kit. So if you're looking for some additional projects, I highly recommend checking that out because that should have a ton of extra projects for you to build up if you would like. So with that, I want to thank you guys for once again completing the 30 days Lost in Space challenge. For those of you who have been with us for the entire 3 years, I've seen some of people in the comments that are going through another time just because they want to see what's changed. Thank you guys. Thank you all so very much for being here for those 3 years. And for those of you that are new, welcome to the community. Of course, join the Facebook group and we're glad to have you. Thank you once again, and we hope to see you guys
Thank you
around.
for the hydrate.
Peace.
Very good, very good. Is my music gonna play? Come on. There it goes. Yeah. So I get to click the button. Boop. Fancy that. Why am I still 86% complete? I reached the end. How dare. Why are we not? Did I not mark something? Ah, okay, so there's challenges here. What? No coding challenge? That seems kind of derpy. Yeah, no, I'm actually kind of curious to see what this is. I didn't notice this before. All right, well, we'll see what we got here.
Welcome everybody to the No Code Coding Challenge, where we only have one rule, and that is I cannot write a single line of code myself. So our team asked you guys what you guys think about AI, and the results were very shocking. Only 1% of you guys think that AI can build faster than you, or that it will fail to make the project entirely. And as you can see right here, either everyone here is a complete genius, or you guys could really use an updated crash course on the current state of AI. This series is going to be doing exactly that. I'm going to make 14 projects without writing a single line of code. That's my one rule. I cannot write it. The AI has to do everything. Each project will be recorded live with a timer keeping track of how long it takes me to make it. If you think you can write the same thing,
I don't want it. I actively don't want it. Okay, so yeah, no. Okay, I have my own reservations with AI, right? It's a pretty big thing right now. It's wandering around the world, and frankly, it's being stuffed into stuff it doesn't belong into. I genuinely like the understanding of what my code is doing, okay? If I don't understand what my code is doing, and I can't find something that explains what the code is doing, then I shouldn't be running it, okay? Because if I can't understand what my code does, at least at a surface level, then we got a problem. You can't debug what you can't understand, and modifying code that you didn't write is challenging. Because as someone who's debugged code that I've been given that was built by somebody else, not AI, just a different person that needed help, I needed to understand the way they thought about the design. And that's hard because I think one way, and that's different than the way you think, and then that's different than the way somebody else's thinks. Working on something that's code generated by a machine may not align with your understanding. Now, don't get me wrong. There's nothing wrong with asking the internet for some syntax on how to write, a statement or two. But to ask something to generate several, 100 lines of code for you, I don't like the idea of that. Sure, I've copied blocks of code to use in my own project, but the thing is that I copied what I knew I needed, ran through it, and made notes so I would understand what it did later. I wouldn't want to do the whole project. I don't like the idea of that, because that relieves you of some understanding of what your own thing does, and to build an understanding on how to operate these different sensors, the way things to wire. I would love to see you to figure out what's going on with why the encoder wheel doesn't seem to work with the hero board, because they kind of got lost in the guided exercise. There's some kind of bug. I didn't know a whole bunch about the encoder wheel other than the fact that there's a map function that allows you to take the spinny bit and map it to fit within a range. Say that you wanted to map the spinning of the encoder wheel between 0 and 10. Well, then those clicks can be encoded to fit within that range, and only within that range. But again, having doing the research to understand what that function is, because I knew that off the top of my head because we covered it in a previous exercise, is because I got to see it and experience it. I'm not going to go any further. I feel like I've made my point pretty clear here. AI, like anything else, should likely be used as a tool, but it definitely should not replace everything. I get it. It's a fun trick to make it write a whole program, but by no means should that be the end all be all. Like, let it write some code, play with it, but by all means do not use it as a substitution for understanding. That's where you're gonna get in trouble. Because that yeah, no, that's a good way to have a bad time for a long time. Yeah, no, and that's just, if I can't explain what's going on with the code, then I don't know enough about it. And having something else write it for me that I'm supposedly responsible for, that's the other thing too, because you have a responsibility to understand what your code does, especially if you're writing code for something that manages something that could involve life or death. If you're writing code that operates sprinkler systems, fire control systems, if you do not know what your code is doing, that's bad. Okay, very important. Something that blinks an LED, not so much, but still, that's very important. Safety is top priority, regardless of what you do. And that has to be baked into how this stuff works. So that's enough of my ranting on that. I am a little surprised. That must have been something new they wedged in here. I mean, it does say bonus, so I mean, I get it. But, so, okay. All right, my bitching aside. Next things to look forward to. Let me get back up here. Where we're at here. So, the Adventure Kit Pandora's Box, or the Part 2 as it's referred to, is currently out of stock, and frankly, it's a very expensive box. This is the product page for it, which allows you to do stuff with water detection sensors, NFC tags, IR remotes, temperature, humidity sensors, motors, relays, sound sensors. There's a ton of stuff here. A much larger, the Hero XL board, which has more inputs and outputs. It's also a kit to the tune of $200 US before shipping and tax. That's a lot of stuff. It's also a pretty big box. But as I'd mentioned, it's very much, I don't want to think of it, the health equipment code. Yeah, no, trust me, as someone who sees medical equipment, I don't want to code for it either. And I'm glad I don't have to, because that just terrifies me. I don't like the idea of a missing semicolon causing something malfunctioning in a medical space. Yeah, no thanks. I don't want that. I want to make fun stuff, because if a fun thing like a light that blinks doesn't blink the right way, no one gets injured. Yeah, no, this, I'm gonna keep an eye out for this, because I tell you right now, I watched, I spoiled a little bit of it for myself, the Spy versus Spy, what do you call it, story path. There's with this expansion, there's the AI Apocalypse, Spy versus Spy, Another Life, and then there's some no coding things that you can toy around with, which again, I'm not going to repeat myself. That's kind of where we're at. The Spy versus Spy guided examples is really cool. It's exactly the same exercises across these 3 guided examples, but you get to choose the adventure. With the 30 Days in Space kit, it was just the 30 Days in Space itself. But with the expansion, or with the sequel to this, there's 3 different video paths you could choose. So I'm gonna keep an eye out for that, because that seemed kind of cool. Time for you to sign off. Oh yeah, absolutely, Satanic. You have a good night. You get some good rest. It'd be getting about that time for a lot of beans. Enjoy. Get some rest. So yes, I saw this, I thought this would be awesome. There's a lot going on here. Now that doesn't leave us completely up the creek. As I had mentioned, there is also the expansion pack, which is the sensors. Let me find that one here. Interestingly enough, it's still on sale. Normally it's $50 US, it's down to $22. They're still on sale and they're still in stock. It comes with a spattering of sensors. Some of which that do exist in the version 2 kit, and some of these that we've seen before. Like there's the rotary encoder, the passive buzzer, and then there's some cool new stuff like a relay, the temperature sensor, there's a pointer laser module, a couple different LED things that are going on here, and then some other different integrated circuits. So some of these we've seen before, some of these are going to be new, which is cool, and the fact that there's some guided examples to go with this is a benefit. So we're going to continue to build on this. I have to figure out how I want to present it, but I do want to start the process of figuring out how to do the build of a proto head and how to bring it to all of you. There's going to be a decent amount of planning. I could tell you the progress on this is going to be pretty damn slow while I go through the research of figuring out what I need, what to print, and then be able to put together a presentation. So it's coming, but it's going to take a decent amount of time. I was watching a couple of videos on making something like this from like beginning to end, and for someone who knows what they're doing, who hasn't built a proto head before, like they've made fursuits before, but they haven't built a protogen head before. It took them like 4 months to do it, and I'm sure that means that it was 4 months in their spare time, but while still having some kind of an idea of what to do. I do not. That's not going to stop me. That just means that my progress is going to be a little slower than someone who already has a clue of what to do. Exactly, the proto building a proto. You got it. So I want to be transparent. I want to do this. I know I won't be able to show everything on the channel, but I can at least post updates in the server. And with what I can present, I'll have here. For what I can't, for one reason or another, then what I'll probably do is do like some pre-recorded videos where I present that live to be able to fill in the blanks for stuff that I just can't do live. I know a good example of that would be to form the visor. If I can't do that, if I can't get a pre-built one, which there's a couple different things you could do with like heating like plastic and forming it, but again, getting that in a way that I could present it, I can imagine being kind of challenging. So I'm kind of all over the place with this, but just know that there is going to be more. That is a thing we're going to do. I will present what I can, and what I can't, there will be pictures and pre-recorded videos. So that's kind of my thought process on that. More to come on that as I work through it. For any of those that you're interested, !Discord to request the link. I will provide it. That is only accessible when I am live. And that is just a anti-bot prevention measure, as there is too many nasty things wandering around the internet, and that is my attempt at trying to keep the community safe. So that is there if anybody is interested. I do have a notes section, so if you're curious as to where my thoughts are on the proto in the process, exactly. and Panic, I know you're in the server, so I am not going to paste the link, but if someone else does that wants access, just ask, and I'll put it in there for you. I debated a couple different reasons about why I'm doing it this way. I have notes of it that there's a server in the description of this channel. I know, right? Yeah, that's probably not what you expected, but it's I'm trying, okay? There's only so many tools that you have for being able to keep a community safe in Discord without, just putting yourself out there for any nasty thing that could find you. And frankly, this is a broadcast, so things could wander by that we probably wouldn't want in the server, and that's okay. But for the good peeps that are out there, by all means, ask if you like access. But yeah, I have a space in there for my running thoughts, and for kind of what I'm going to use as a space for me to keep track of where I am in the process of this project. Because not only do I have to, design it, and build off of, hopefully with some templates I can find. We'll see how it is. If the approach doesn't work, well, then I'll make adjustments. But I think for now, I think this will make sense. This is what kept me from publishing the Discord server for a decent amount of time, is presenting it in a way that it's accessible for those that, will ask. But also not putting it so that it's, easily exploitable. Or at least attempting not to. But yes, we're going to use the server to keep track of my thoughts on that, and then any progress and updates. I also have a section where if any of you would like to share any suit building tips, I made a channel for that in the server. If there's anything you'd like to share, I'm going to continue to dump stuff in there myself just to help me organize, keep my thoughts in order, but also any of the links that I also find that are going to help me figure out, the other aspects of this. With any major project, There's going to be bumps in the road. There's going to be stuff the hurdles that are going to have to be figured out. I'm sure I'm going to hit multiple roadblocks in the process of trying to figure this out. And I'm here for it, and I'm excited for it. I love the fact that one of my friends, Dragoness, is in the process of making her own suit. Not a prude, but that's okay. And she's made some amazing progress in the building of her suit. And I very much love the fact that she jumped headfirst into it. And I'm going to be doing something similar, but there's going to be a decent amount of planning because I have to figure out how electronics are going to build and fit into something that's partially 3D printed. So we're going to get there. And I'm excited for that, very much so. That's pretty much the updates I have on that. I'm going to continue to cycle in the retro games and some non-Arduino things. I'm kind of a bit split for what angle I'm gonna take right now. I may branch into doing some other things on here. I'm starting to run onto some of the backlog I had of retro games. I'm starting to dry up on that, so maybe we'll see about doing some other stuff. But and we'll see where we can end up with that. So I still want to continue to do stuff on here, and I would love to mix the two together because frankly I like playing games in addition to presenting educational stuff. The whole point of why I made this channel is because I wanted to be able to present cool stuff in a way that was hopefully easy to understand. I know these exercises have gotten pretty far out there and a little out of scope of what I would consider easy to understand. But I'm hoping I present this in a way that at least makes sense, even if you don't quite understand what the code's doing. Frankly, I don't understand what the code is doing in some of these cases. But that just requires additional research on my part to further understand. That doesn't mean it's a stop. It doesn't mean it's a gate or a wall. It just requires more time to figure out. And that's learning, that's life. I forget who it's a quote via, but they say that your tombstone is your final diploma because you're always learning. And honestly, it's a decent way to look at it because the world's not stopping anytime soon. So we might as well have some fun along the way while we tinker around with what silly electronics I can manage to find us into and play some silly games along the way. I like that mix of things, and we'll continue to do some fun things. So with that, let me see where I can wander us all off to because I am about finished for the evening. I started a little later than I normally do, but that's okay. Hey, Mountain Man, I love your proto. Yo, chat. This is the OSHA protogen. This individual has made their proto head, and I'm hoping to leech some wisdom out of them. As I start to have questions as I attempt this process of building one of these myself. Yes, it's amazing and it's awesome because if you go into what VR chat world is that? The furry hideout. You will see Mountain Man's proto. Trust me, you'll know it. I don't have to even describe it. just the hard hat will give it away. I love that. That's gone? Really? They must have recently took that down. I feel like I was in there a couple of weeks ago and I saw it. Huh. Fair. Well, I mean, hey, it was a cool thing. I mean, it was a picture from a convention, so I could get it that they would have did that. Oh, 1 day ago. Okay, all right. So I'm not too far off the mark. All right, chat. We won't be able to see it there, but I know there's pictures of his proto on my server. I love that. I actually love the way your suit came out. It was so cool. Let me see where we're doing stuff here though. I mean, maybe, I don't know. I mean, it be what it is, and it ain't no big to do. It's cool though. Let me see, where can we go? Oh, I know where we could go. Okay. Ooh, you're working on chest plates. Ooh, mighty fine. Yeah, my main focus is going to be figuring out how to build the proto head. Oh, Mountain Man, since you're here, did you build your electronics based on a Raspberry Pi, or did you do an Arduino? For what displays the faces? Because I've had a couple guided examples that were using a Raspberry Pi and the I/O shield that was on that. Okay, so you did the Raspberry Pi version. I don't know if I'm going to be right in trying to do this with an Arduino, but I feel like that's the angle I'm going to attempt. And if not, I'll use a Raspberry Pi. Yeah, I mean, this whole 30 Days in Space thing being Arduino based, and the fact that I still need to figure out how to make my own custom bitmaps because every one I've made doesn't look right, so I have to figure that out. That's one of the roadblocks I got to figure out. The P3 panels. Okay. Yeah, I saw some guided examples where you can join the panels together and like profit, and it just work. So, but I mean, so do the displays do on one of these. It's just knowing how to code it, which, haha, something we have to figure out along the way. Again, hasn't stopped me before, but it's such a big project. I'm so excited for it. Also kind of terrified at the same time. Just hoping it's not going to take me 3 decades to do. It is a huge project. I'm not minimizing that either, because I know that to be the case, but that's not scaring me off. I know it's expensive, I know it's time consuming, but it's also would be the absolute coolest thing I have ever put together. So I want it. I want to do it. Something that, again, I know I have to talk and think about my design, but the side of my proto head, my come on, hand tracking, do the thing. The wiring diagram that's on the side of my visor head. I showed it to you all before. The custom PCB board that I ordered, or that I designed and assembled here on stream before. There's a reason I did that before wanting to build a proto head, is because I want to make my own custom side plates that I'll wire into everything, so that I can actually have the colored LEDs to match up with the wiring diagram that goes with an Ethernet cable. I'm going to incorporate that into this proto head if it kills me, because it's something I know for a fact I can design, because I've already done LEDs before and did the thing. So I'm doing that, but I have a lot of other things I have to get over first. I know this will be more of a finishing item as I figure out the rest of the electronics. But yeah, took about 9 months, and the community can be odd, but they are great help out there. That's totally fair. I very much appreciate that, a bunch. I definitely plan on continuing to do updates in the server. And Mountain Man, buyouts, if you would be a dear, if there's any resources that you have that you use to build yours, if you could put them in the channel I made for building fursuits, please, for the love of God, share them. Because if you have anything that you think would be helpful for me, I would love that, because I'm still going to be very much in the whole concept of research all the things. And I've gotten a couple of recommendations in there already from a couple other community members, which was greatly appreciated. I so want to do this, but oh god, it's gonna be so crazy. Oh, I'm excited and terrified at the same time. It's not, see, I'm not even worried about the idea of failure, because you don't fail at something like this, you just succeed at a later time. I'm just hoping that later time won't be too far into the future. That's the way I'm gonna look at it, and that's the way it's going to be. Case in point. So yeah. Gaia. Well, my plan is to 3D print the base pieces myself, and I'm gonna get the STL files and build that stuff, and then from there, I have to determine if I'm going to build the visor myself or if I'm going to attempt to order that from somebody. Right. The standard size. I think I might be able to get away with the standard size. I got to look at the dimensions though. But again, there was a couple different designs that are out there that I was looking at. I was perusing this morning at them. Because I know as a project, this is gonna very much use a lot of time. Oh, out of curiosity, did you use a sewing machine or did you just do a hand blanket stitch for the fur when you were working on the ears? Because I know Dragoness, she's been doing the blanket stitch, which right. No, I remember yours was upscaled for personal reasons, which was totally fine. I need to do the let's see here. Can I use the tab command on this? No, but if I spell her name right, yeah, this is who I'm referring to. I'm gonna give her a shout out. Purple Cat Dragoness, she's an absolute sweetheart, but she's also actively in the middle of building a fursuit. If you like that kind of content, go drop her a follow because she's in the middle of building a suit right now. She's gotten a decent amount of the way through building some of the head, and she's been doing a lot of hand stitching to build the ears, the fur. I think she was working on the tail the last time she was live, and this is also her first experience in building a suit. So if you like crafts and stuff, she's definitely someone to go say hello to. Help to keep it clean. Okay, all right. See, yeah. You hand did yours, right? And I was thinking about doing the same. I am more than content with taking the slow and steady route to get not only the stitching correctly, but something that'll work. So there's certainly that. All right, cool beans. I will probably hit you up with more questions in the future, but that's all I have for now. Thank you for answering my questions. Getting a history document through whatever you listen to in the background because it's tedious. Oh yeah, God, yeah. Oh. I lost my clipboard. Hang on a minute. Please tell me there's still yeah, I'll certainly see you later. By all means, thank you for stopping by. I have to find their name again. Oh, there. I cleared my clipboard. There we are. See. All right, there we go. All right, so we're gonna go off to Cad Pig, also known as Caddy, who is a very fun streamer that is in the middle of doing some Lego things. So in the continuous of the theme of making cool stuff, we're gonna go say hello to someone who's building cool stuff, because who doesn't love that? I will catch you all back. I do this Wednesdays at 6:30 p.m. Eastern Standard Time, and yeah, I'll catch you back for next Wednesday. We're gonna continue to do something. Retro stuff, electronic stuff, me just blabbering about electronics. I don't know. We're going to do something. This is fun. Thank you all very much for stopping by, and I will see you in the next one. Bye-bye.